Ted's getting the camera set up and our speaker's getting antsy. I'm going to go through the administrivia. It's Sunday morning at ShmooCon. Everybody had a good night? This is a lot more people than I thought we were going to have, which is good. Did it really? The tab lasted until 11? Holy cow. That's not bad. That's a pretty big bar tab, too. I mean, it's tough to walk into a bar and just write a check before you start drinking, and so you always wonder, like, are we going to drink that much? Oh, yeah. Yeah, we're going to drink that much. But I was shocked. They came back here early. There are people working on the contest. There's a lot of stuff going on. A lot of people hit the rave next door, which was fantastic. Apparently, it was quite a good rave. So next year, maybe we can, like, have a commingled ShmooCon anime thing, and you can all dress up as your favorite hacker character. There aren't many. Everyone will dress up as Captain Crunch. I mean, that's the easy one. You go yourself the whistle and you go. So a couple quick notes. For those that are doing the badge contest, I know there's a number of folks. Clue number 2 is posted above the registration desk now. I think it's helpful. Question mark. If you're doing the contest, it should be, and if you're not, it probably won't give you any more insight as far as how to solve the badges, because it's relatively complicated. Not that you're not smart and all. I didn't mean to imply that. You just hung over. Room split, 1 o'clock. And we'll just be reminding you of this all day at 1. Just leave the room so we can sort this out and make this one big room. We'll have the closing plenary and closing remarks after that. Doors. We have doors in these rooms, and people come in and out of them. That's the nature of the doors. The doors make a lot of noise, and so do the people in the hallway. So 2 things. 1, try to go in and out as quickly as possible. But 2, try to use your ninja-like skills so the door doesn't make a lot of noise. There is like a process to do that where you can open the handle, and you open the door, and as you close the door, leave the handle kind of pushed or open or whatever, and then shut it, and it doesn't go click at the end. Because I think some speakers are thinking about bringing in weapons and solving the door opening problem themselves. So just try to be aware. It is a bit of an issue. And finally, feedback forms. Please, 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 please fill out the yellow feedback forms. I don't care if you have to do it from memory from yesterday. Please do it. It's very valuable to us as a conference organizers to know what worked and what didn't. We kind of go out of our way to try to give people an opportunity to talk that maybe haven't been able to get on stage before and present their ideas, because we want to be able to get new ideas into the community, and it's important that we get feedback on those speakers to help us out on selection and to help these speakers out to do a better job in the next go-around. So if you can fill those out, at the end of the day, there'll be a box at registration. Drop them off, or give them to any staff member on the way out. You can even crumple them up. We'll take care of it. Just get it to us. Speaker feedback forms, I think a couple years ago, we barely had enough data points, maybe 2 data points per speaker, and there were 800 people here, so that wasn't really cool. So please give us more than 2 data points. Just write down your thoughts and send it in. And I think that's all the administrivia. Sir? Oh, it's coming back up. Sweet. We were down a projector. This time it was the other projector that's flaking out today, so we'll see if we can keep them both up. Dan Griffin's going to talk about Vista Security. You're not with Microsoft, correct? Excellent. Black Hat, a couple years ago, had a track of Windows Vista Security that was all like Microsoft employees, and I thought that was kind of an interesting way to tackle that problem. Am I supposed to give these away? Oh, man. I'm so bad at the giveaways. It's not even funny. So we're just throwing it over here. Now, I'll come up with some long, convoluted question. Has anyone played Galaga yet? All right, sir, your hand was the first. What was your score? 25,000. So you at least crested the 20,000 mark. That's good. For you, we have a special Shmoo limited edition multi-tool thingamabob with the eyes on it, and a fantastic shirt from O'Reilly that prompted my son to ask, "Hey, what's animal magnetism really mean?" It means they like each other. Software developers in the room. How many software developers? Language of choice.
C.
English. There you go. Who was that? All right. Here, come here, sir. You can get yourself writing great code, thinking low level, writing high level from No Star Express. That was the kind of answer I wanted. So thank you very much. Dan's going to school us on Vista Security. Please, God. If I can make one comment, I think Microsoft is doing a rather interesting job right now trying to solve some pretty complex security problems that most of the academic and commercial community has left on the table for the last 20 or 30 years. And it's interesting to see what state Vista's in and what we're able to do to it as an operating system. So I'm actually very curious about this talk. But we've actually kind of gone beyond this Windows bashing stage and have entered a point where maybe Windows isn't starting to suck as much. Yeah. Yeah, I'm sorry. I mean, yeah, most people have already packed their smooth balls. But I think the open source community is going to be in for a run for its money here shortly as Microsoft gets its system really in gear. So anyway, I'm curious to hear what you have to say, but unfortunately I have to go do other stuff, so I'll watch you on video. But here's Dan.
Okay, can you guys hear me? I only heard smart-ass remarks, so I believe that means yes. Thanks a lot for coming out. I know first talk the morning after the party, you guys are the hardcore ones, and I recognize that, so again, thank you. And you'll notice that I'm losing my voice for similar reasons. My name is Dan Griffin. I'm a software security consultant in Seattle. I did actually used to work for Microsoft. That's how I learned most of what I'm going to talk about tonight, this morning, sorry. But I don't work there anymore. These tools that I'm going to show you, there are 4 of them. 3 of them were written by my company on contract for Microsoft, the code anyway, on contract for Microsoft to be MSDN samples. The first one is actually not in that category. That's just something I wrote for myself. But what's interesting about these tools is that, well, for one thing, it's kind of rare for Microsoft to actually create MSDN samples that are useful. And I think that these tools actually show a useful solution to a problem in kind of an end-to-end way. And they also expose some security questions. So I think that's also a rarity for MSDN samples. Although if you've ever cut and pasted code out of MSDN, you should know you've created security problems, just so you're all aware of that. Okay, so this code that I'm going to show you is C and C++. I'm not going to show any C and C++ today, but unless you're pretty comfortable with those languages, you're probably not going to be real comfortable with playing around with the tools. So apologies if you're not a C programmer. The code is free. Again, except for the first tool, I haven't decided to make that code available yet. If you're interested, we can talk about that. The topics are smart cards, crypto, firewall, and IPsec. Here's the first one. Hacking smart cards. What I'm going to show actually is fuzzing smart card middleware. Okay, so just to get the dumb questions out of the way first. What's fuzzing? Fuzzing is a software testing methodology wherein you're sending random inputs to a program, and then you see what happens. And typically you're rewarded with the program blowing up in some way. What's a smart card? A smart card is one of these. It's basically a credit card with a SIM chip on one end. A lot of people in the US probably haven't seen a smart card before, or at least maybe you've seen one but not actually used one. Anyway.
Pretty much everybody working for the federal government in DC is
Thank you, thank you. So I'm pre-selected for people who have been exposed to smart cards here. Good point, thank you. There are other form factors. You can basically take the SIM chip and put it in a USB key fob, which is also pretty common because you kind of get a 2 or 3 for 1 there in terms of what the device can do. What's smart card middleware? Middleware is basically the operating system plugins that are required in order to know how to talk to a specific smart card. Generally, each vendor's card has its own command set. Some are pretty similar, some are totally dissimilar. So you need software that knows how to do that. I just want to do a quick, this is probably the scariest of the 4 diagrams, but it really actually makes a lot of sense. Let me just explain it. I just want to show the data flow here as data is read from the smart card and gets up into specifically the demo program that I'm going to show you that we're going to blow up. So starting at the bottom of the diagram, I take the smart card and I insert it into this USB smart card reader. And as a result of that, the operating Vista specifically, actually all versions of Windows since Windows 2000, will automatically read data from that card, just from the act of inserting it. So the data is read from the smart card into the reader device, that's arrow 1. Arrow 2 shows the data traversing the USB stack into the smart card reader driver. Okay? Arrow 3 takes us out of kernel mode into user mode, where we're now into a system service called, I call it S-Card Server there. It's the Smart Card Resource Manager. And the purpose of the Smart Card Resource Manager is basically just to be a dumb pipe between the applications and the smart cards. But it also allows applications, each application in turn, to have its own control. Otherwise, you'd have a bunch of gibberish if a bunch of apps were trying to send commands to the cards. I mean, these things are dirt simple. They're real dumb. So you have to have some logic in the PC to make sure that the communication is successful. S-Card Server does that. And then the 4 and 5 arrows branching out. 5 is an example of the data flow to this system service, for example, that always reads data from the card when you insert one. 4 is showing the data flow to, for example, a smart card aware application, such as the one that I wrote to demonstrate fuzzing the middleware. Okay, so referring to that block on the right, the bottom box there, WinScard Client, that's just the API, the Windows API for sending commands to the smart card. So it's basically just an RPC shim over to S-Card Server. Okay? But because that interface is so well defined, it's a really easy way to put a hook in and perturb that data flow. And that's exactly what my fuzzer does. So in other words, my fuzzer kind of inserts itself between the WinScard client and the smart card middleware, the piece provided by the vendor, so that in some cases what the middleware is receiving is actually not what the card sent, it's what I put there. And then just to complete the picture, on the right-hand side there, the top 2 boxes, I'm a lazy developer, which I think is a good quality for all developers, by the way. So I just wanted to make this as simple as possible. And there's some kind of high-level crypto APIs in Windows where you can basically just call a single API and it'll load the smart card and initialize the whole stack and everything for you. So I'm just calling that API to trigger the whole demo. Any questions about that? Okay, so let me show you the demo. This is actually pretty simple in principle, but I'm going to be showing it in the context of a debugger, so it gives it kind of a sexy, really technical, scary look, you know? And of course, since I worked at Microsoft, the Windows debuggers are my preference just because that's what I learned, but obviously you could do this in any debugger. Okay, so let me just explain a couple things of interest here. S-Card Fuzz is my demo program. The demo, I think at the end of this, you might think that the demo is a little bit contrived, but it's really not. And so give me a second to explain why that is. And finally, look at the last static dependency here before I run the program. This is the DLL that I wrote to do the hooking. So if we go to the third static dependency, recall that this is the client API for sending commands to the smart card and receiving them. Okay? I'm going to use my DLL to go into the vendor's piece, the vendor middleware DLL, and replace the import for smart card transmit from WinScard with my own smart card transmit, the evil smart card transmit. And then in some cases, I'm just going to call directly over to the built-in one and not change anything. And in other cases, I am going to change stuff to see what happens. So that was it. I go to the debugger, and the application crashes. Access violation. What happened? Let's see. The reason that's interesting is that, so you can see here S-Card transmit being called a few times by the vendor middleware in response to that crypto API call that I made. And actually, I like that the display is wide. By the way, I think you guys can probably see that. Everyone can see that, right? Okay, maybe that side's blurry. Well, sorry about that. Anyway, the first command that is always sent to the card whenever a card is inserted is to read this file called card ID. And it doesn't matter what kind of card it is. So this hack applies to any vendor's card that's compliant with this smart card stack. My point is that you can predict the commands that are being sent. So in response to receiving this command, the smart card receives this command to say, hey, I want to read the card ID file, and I want you to tell me how big it is. So here's what the card sends back. The card says, hey, I have a valid response for you. I believe what 61 is, I have a valid response, and it's 1 byte long. And it says, okay, you need to read 1A bytes, which is what, 26 bytes decimal, right? Now, I happen to know that the card ID file by spec is only 16 bytes long. It's a GUID, basically. It's intended to uniquely identify every card. For some reason, there's a bunch of metadata that this particular implementation includes with that 16-byte file. So there must be 10 bytes of metadata that it also wants to return. Okay? I lost my mouse here. So then, this command is the application saying, or specifically the middleware saying, okay, well, go ahead and send me that 26 bytes. And here's what the card says. The card says, okay, here you go. Here's a bunch of metadata. And then here's the actual interesting payload of that file. Here's the 16-byte GUID. And here is presumably a length tag, 16, right? And then the last 2 bytes, 9000 in the smart card speak, means everything's cool. I'll say up front that I actually don't know what all this metadata is. I mean, I don't have access to this vendor's code or anything, and it doesn't really matter, quite frankly. Because what I do is instead of, in this case, instead of passing this return data up to the application, I replace it with a bunch of garbage. And so let's see what the garbage I used is. You can see that actually, this is interesting because this is a case I haven't run into before. The nice thing about fuzzing is that I use truly random data, so you never know what you're going to get. You can see that I actually modified some of the metadata here. So before the bytes were 00, D2, 5D, etc. Well, what I actually sent to the middleware is not those bytes up to, it would appear, the 5th byte, and then the rest is the same. So what's interesting is that I didn't change the GUID at all, which shouldn't matter, but I also didn't change the length byte, which I usually do. And so what that tells us is that this metadata does something pretty important, because as a result of fuzzing this metadata, I caused a heap buffer overrun in the middleware. That's what this access violation is. And if you look at this address here, 98400, that it tried to write to, that's in the process heap. So that's pretty interesting. There are a couple of important takeaways here. One is, this vendor clearly assumes that it can always trust input from its smart card, which you might think is a reasonable assumption, but it's absolutely not. For one thing, no software has any business making assumptions about trusted input. I mean, that's bullshit, right? You can't do that. 2, cards in general, and actually including the DoD smart card that you mentioned, and this one, now have VMs on them. So what that, as in a virtual machine. So what that means is that you can write a Java applet or a .NET applet, like write some C#, in like 3 lines of code that would actually do this, what I just showed you, without having to install any software on the PC. You wouldn't have to install my hook. You just write the bogus applet, replace the applet that's on the card with that, and now you can send all the crap you want to through the middleware. And it's not expecting it, obviously. So what that means is that if you walk up to a Windows PC that already has the driver loaded, or already has the driver ready to install for one of these interface devices, and that already has the middleware for this card, and you have a bogus applet on your card, you're going to take out this process. So that's pretty fun. I recommend that you go home and play with that. That's it for this demo. Any questions about that? Okay. Sorry? Yeah, so if you want to play with it, I'll give you the code. I am going to scrub the code for the vendor-specific pieces. I don't want to kill this vendor any more than I have to. And by the way, this vendor, I have engaged in responsible disclosure here. This vendor knows about the bug. I was told it's fixed, but honestly, I didn't verify that. And it's obviously not fixed on my Vista PC, so. Oops. Okay, the next demo is hacking crypto. This is just a quick demo, and again, now we're back into the territory of the samples that I did for Microsoft, or that my company did for Microsoft. What I wanted to show was how to plug in a new crypto algorithm to Windows, and I realize that this is kind of a fringe thing probably for most people in this room, but the fact is that there is demand for this, because Windows only ships with a limited set of crypto algorithms supported, and you actually don't have to look very far before you find an algorithm, for example, that's used in open source that's not supported by Windows. And if you have any familiarity with doing government contracting or anything like that, especially for non-US government contracting, every government has their own crypto algorithms. And so there's a lot of demand among that set of folks for being able to do this. And there was no sample code for it. Poor documentation, as usual. So that was the opportunity I pursued. What I'm showing is a plug-in to this new crypto API that Microsoft has in Vista. It's called CNG Crypto Next Generation. In the crypto stack, you can see on the box on the far right there, CMS API. CMS stands for Cryptographic Message Syntax, or Messaging Syntax, or something like that. It's just a standard, an IETF standard, for example, that's used when you send a digitally signed or encrypted email from Outlook or Thunderbird. That's the encoding standard, basically, for that email. So what I'm showing is, okay, I can take this code, this implementation of Twofish, which I'll get to in a second. I can download it off the internet. I can stick it into this wrapper that I wrote, and now I can actually send an encrypted email with Twofish. So I think that's pretty cool. It's a pretty leveraged sample in that way. So briefly describing what the demo does, I didn't actually want to run this demo in the context of Outlook because I need Outlook to work all the time, and this is demo code. So anyway, TF test, Twofish test, the top box there simulates Outlook. The first thing I do is I call into this CNG, this new crypto API, and I say, hey, give me a Twofish key. And it says, oh, well, let's see if I know what a Twofish key is. And it looks up, you see arrow number 2 there, it looks up the DLL that I registered, that I wrote and registered, this Twofish implementation. And it says, okay, TF test, here's your Twofish key. And then TF test goes over to this higher level API, this messaging API on the right-hand side. You see arrow 3. And it says, hey, here's my Twofish key. I want you to encrypt the message and encode this key to the following email recipient. Okay, so this demo is even more low-tech than the last one. The smoke and mirrors here is that this Twofish DLL, I've already installed that into the System32 directory and just ran regserve on it. So it has its own registration payload in it. So there's no special tricks there. So that's it. What it does is it just creates a new recipient certificate. Obviously, obtaining the recipient certificate is a non-trivial task. I mean, that's the whole point of public key infrastructures, and I don't mean to gloss over that. I realize that there's a significant amount of infrastructure required in order to actually do this in a deployment. Just ignore that for a second. Then I create a 256-bit Twofish key. Sorry, I forgot to explain what Twofish is. Twofish is a symmetric encryption algorithm invented by Bruce Schneier and his group as their submission to the Advanced Encryption Standard in 2000. You guys probably are aware that it did not win. But it's still considered to be secure. It's been reasonably cryptanalyzed. Like I said, I've actually seen it in, I don't remember if it was in GPG or maybe some SSH variant. Anyway, I know it's used. Yeah, I'm seeing some nods here. So anyway, it's out there. And it's not in Windows. So I create a short test message. I encrypt it with the key. I send it to the CMS stack. And what the CMS stack does is it takes the public key in the recipient certificate, and it encrypts my Twofish key, and does the ASN1 encoding of the whole blob, and pretends that it's what would end up being an email message, and then that's it. And I just unwrap that whole process. So I take the private key that I created in the first step, I decrypt the Twofish key, and then I use the Twofish key to decrypt the message. And then I just do a mem compare to make sure that I got the same message out that I put in. So I promise not to show any code, so I'm not going to put that in the context of any code. But this you can download, and you know, there's actually a full article. I just remember there's a full article that comes with this, so it's very clearly explained. So I do recommend, if you're curious at all, you can check that out. Okay, another sample that was prompted by a complete lack of documentation. Vista has a new firewall API, and what I was finding is that you know, the samples weren't sufficient to show application developers how to properly use that API. And actually, I'll just show you the demo because it really motivates what I mean by that, why application developers, I think, really have some learning to do here. I think there's some homework that they're not doing, so to speak. Before I get to that, I do like to talk about the architecture of what I'm about to show you. This diagram is actually probably makes it seem more complicated than it actually is, this demo. But anyway, if you look on the FW toolbox, kind of in the middle there, above arrow number 1, that's my demo tool that shows you how to call into this firewall API. And the whole demo that I'm showing you, actually, it accomplishes that with a single API call. And so the point is, FW2, or a firewall tool, obviously, arrow number 1 shows that it calls into the firewall API and then sets up some firewall rules, or a single rule, as a matter of fact, in this case. Then there's a client program that I've created, that I've provided in the sample, but I'm actually not going to show in the demo. There's a client program, stcp-cli, on the left-hand side, calls to arrow 2 into the TCP stack on a Vista client, or actually any client for that matter. And then arrow 3 shows that, you know, that request is either blocked or accepted by the firewall, depending on the rule you've created. And then conditionally traverses the TCP stack on the server in arrow number 4. Arrow number 5 shows the server component of the sample socket client and server programs that I include, again, so you can test this, obviously. STCP serve just opens up a socket and listens. So very simple code. So what happens is this. I'm going to run the listener. And when I run this listener, look at this beautiful dialog that the operating system gives me for free. It says, hey, Mr. User, this is the first time you've ever run this program. Here's a bunch of crap that you are not going to understand. Please select a button. So you can roll the dice at this point about what your user is going to select, right? I mean, this is terrible. And I am not faulting Microsoft for this, and I am not faulting the user for this. If you provide software that does this, you have screwed up, because your users are going to get it wrong. And then you're going to have a support call, and everyone knows that's expensive, right? Anyway, so I'm going to say unblock, since I happen to know that that's what I want. And let's see what the result of clicking unblock is. Oh, I adjusted this for a smaller resolution. Just a second. That's still working. That's still working. So sorry, that's probably minuscule type. Anyway, let me just explain what's happening here. This is the firewall management interface that's built into Windows. Oops, sorry. Okay, so let me try to get it so that... So at least it's the 2 at the top that I'm talking about. Apologies, you probably just can't see that. Anyway, what we see here is that as a result of me clicking unblock, there are 2 rules that are created on my behalf. And the bottom line is that these rules allow every kind of traffic into this application. So that's a second way in which the application developer has screwed up by not creating their own rules, because you're allowing traffic that you should just not be allowing into your application. I mean, come on, let's have some defensive programming here, right? In the columns, let me just describe what these columns here in this view can tell us. First of all, you'll notice that the column includes the full path of the program, this stcpserver.exe that I ran. I'll get back to that in a second. All TCP traffic is allowed. All UDP traffic is allowed into that app. Any local port from any remote address, and a bunch of other any's here as well. So I submit that we can do better than that. So I'm going to delete those rules. Kill that. And then I will run, I got to remember the port number, 27015. So I'll use FWTool, the demo program here, STCP server 27015, client address range, I'm going to say local subnet. Let me explain what I just typed. Firewall tool has an option to add a new rule, and it tries to make it as tight as possible. You have to specify this, the second parameter here, STCP server. That has to be the exact name of the program without the extension, in order for the operating system to recognize that as the matching rule set when the application runs and not give the user that dialog prompt. Okay?
So all you would have to do is name your application as something that you already knew was registered.
Yeah, we'll get to that in a second. We'll get into that in a second. Come on, give me a second here, man. Jeez. Yes.
Two questions. One, does the firewall, does this add UDP and TCP traffic, or can you limit it to just say, hey, add only TCP?
We'll get to that in a second, too. Okay, application name, port number, duh. Local subnet for the client address range. That local subnet, quote, 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 is actually a mnemonic that's provided by the firewall API. And so there's magic in the stack, in the networking stack, to translate that string local subnet into the proper net mask. Now, I am not going to assert that that translation is proper in all cases. So you've got to test this, because I have not tested that. It seems like a little bit of voodoo that could easily be gotten wrong. Anyway, that's what I'm going to use. Okay, so that's created a new rule for us. Let's go back to our view here and refresh and see if we can find the new rule. Oops, I clicked in the wrong window to refresh. Okay, there it is. So sorry, I don't know right off the bat how to make that bigger. Anyway, so now we've got one rule, and I'm not going to claim that it's as secure as possible, but my point is to show you that it's a step in the right direction. I am only allowing TCP traffic to the gentleman down in front. I'm only allowing this program to listen on a specific port, and I'm only going to allow traffic to this application from machines on the local subnet. So you can come up with a scenario where you might want to use local subnet. I don't know, maybe if you have a file share or some file sharing program, I guess, that you only want to be used by your work group, or maybe a database server. Anyway. And you can see that there's some other metadata here. The rest of the any's, local address any, remote port any, allowed user any, allowed computers any. Those are all additional parameters that you can stuff into this API that the sample calls. So you can control all this stuff. It's really easy. As a matter of fact, before I get to your question, as a matter of fact, you don't even have to use C and C++ for this. You can, for example, script a call to netsh.exe. You can use VB script. You can use COM. You could use COM interrupt for managed code. My point is, whatever you do, if you're providing a network-aware application, and specifically if you have an installer for it, which you presumably do, you should be setting up the proper rule in your installer. And also, don't forget, in your uninstaller, to roll back the proper rule. To your question. Okay, so the question was,
Can you just name your application?
Thank you.
A name that you already know is in there and bypass being prompted?
Here's what you can do. I'll repeat the question in the form of the answer. You'll notice that part of the rule, one attribute of the firewall rule, is the full path of the application. Okay, so that seems kind of promising, right? That could mean something good from a security perspective. And it actually does. If I were to try to run STCP server from a different location on the, on the local disk or whatever, it would not match this rule. So that's good. What perhaps leaves room for improvement is that that's not a strong name, for example. So if I were to say take netcat and rename it to STCP server and put it in the same place, Now netcat does match that rule, okay? Because it's STCP server at that point from the perspective of the firewall. So what Microsoft should have done is they should have done, a hash. They should have done some sort of hash-based feature.
Again, it's more interesting on a block rule. On a block rule, the full path doesn't match, it doesn't apply.
On a block rule, the full path doesn't apply.
We said we didn't want to allow that program access to that port. If it was copied to any other path, it wouldn't apply.
Thank you. Any other questions about that?
You didn't pass a path to your EXE, and yet I see in the firewall.
Yes, sorry. He just busted me on some demo voodoo. I did not pass the full path when I set up the rule. Under the covers, FW tool assumes that the program you're adding is in the same directory as FW tool, and it expands the path out for you, so I don't have to type as much when I'm sitting here doing demos and type it wrong and it fails, You could do, obviously at the point where we're running C code in Windows, you can do anything you want. So, yeah. Yeah.
So if you use a signed executable, did you check for signed?
No, the question was if you use a signed executable, will you get some of that strong name benefit? No. I'm told that that's a feature, the strong naming feature is kind of on the table for a future version of Windows. But, I haven't heard any sort of commitment about that or exactly how it would work.
So if if you've got a Trojan writer out there, they can just make all these calls before opening up their network socket, and you'll never get the little pop-up even telling you that it's going on?
Absolutely. You have to make the calls. To repeat the question, let me rephrase the question. I think the interesting question here is what rights are required in order to create firewall rules? And you have to be an administrator. So if you're a Trojan writer and you've got code running as administrator, who gives a shit if you can open up firewall rules, dude? It's done, right?
So in that scenario with your typical business situation, it's going to kick out that same thing you want to run with administrator that scenario.
Yes. If you're running your Trojan as the user and you're in this elevation situation, you're going to get another one of these prompts to the user that says, hey, do you want this application to do something nice or just to fail? Right? That's what the elevation prompt amounts to. So I would counter that you're still in trouble at that point. Right? If your user gets the prompt asking if they want to do something really dangerous, they're always going to click yes. So yes, you have to be administrator to do this, but I don't think that in particular is going to protect you. Okay. Okay, last one. There's a buddy of mine, his name is William Dixon. He does some consulting out here, and actually he's back in Seattle now. He's a big-time IPsec expert. He also used to work at Microsoft. And at the time when I needed to come up with another proposal for sample code for Microsoft in order to get the money, he came to me and said, hey, there's a big lack of IPsec sample, IPsec programming sample code. So why don't you do that? And I said, oh, thank God. So that's what this is. And specifically, the second bullet here, WinSock Secure Socket Extensions. What that amounts to is a new set of socket-related APIs in Vista that allow you to specify some security requirements, some security attributes of a socket before it's opened. Okay, what does that mean? Again, the semi-scary architecture diagram, but bear with me here. The name of the tool that I wrote is IPsec ping. So it's basically ping, except with these socket extensions, built into the socket client. IPsec ping calls WinSock to try to open up a socket to a port specified on the command line to a server DNS name also specified on the command line. Okay, we'll obviously get to this in a second. As a result of setting these new socket parameters, you see arrow number 1, there's a call being made over to, I'm not sure if, I confess, I'm not sure if WinSock is calling IKE directly. I may have this part of the diagram wrong, so forgive me for that. There are probably some experts in the crowd who can correct me on that. Anyway, as a result of these parameters being set in the client socket call, there is a call over to IKE. IKE is Internet Key Exchange. It's a system. It's a system component in Windows that initiates the key exchange protocol on behalf of IPsec. So the first thing that happens is IKE says, "Ooh, I need to try to see if there's a matching policy with this machine with this server that he's trying to connect to, and I need to see if I can negotiate the key with that server." So in order to negotiate that key, IKE has to start sending packets to the server. So that's arrow 2. IKE is calling into the network protocol stack. This is all IP at this point, right? There's no TCP yet. Arrow 3 shows, the communication over to the other side, to the peer, the IPsec peer in this case. And that communication bubbles up in arrow number 4 to the IKE entity on my peer, the Internet Key Exchange, service, I should say, running on the peer. If this negotiation is successful, arrow number 5 shows that now we start doing the TCP negotiation. We see if we can bring up a TCP connection. If the IKE negotiation fails, we're never even going to try to connect TCP. So that's kind of the main point of these new socket APIs. They allow you to place that restriction that the socket never opens unless it's secure. And this is the client stipulating this. Obviously, it can be stipulated on either or both sides. Any questions about that part? And then I'll show the demo. Okay. Okay, so again, I wrote this with my buddy William Dixon. He is definitely the IPsec expert here. That is not me. So here's the tool, IPsec ping. What I want to do is verbose. I want to do IPv4 addressing, and I want to connect to the machine called JW Secure v9. Look at that. Okay, so just for the record, that's a live demo of IPsec on a laptop. That's not something you're going to see every day. Thank you, thank you, thank you, thank you. I'll get you your beer later. So just want to show some of the output of this tool, because I just think that this tool has the most scary and yet sexy technical, like, gobbledygook output that I've ever seen. I'm extremely proud of it. Thank you. Thank you. I'll get you your beer later. Yep. Okay, so obviously we're trying to connect to the peer machine that I specified on the command line, JW Secure-V9. In case I didn't make that clear, that's a VM running right now on this machine. Okay. That's the address. That's the IPv4 address. We're connecting to the default port assumed by IPsec ping when a port is not specified on the command line. 135. I'm sure I don't have to tell this crowd is the RPC mapper port. Lots of fun stuff happens on 135. We assume that it's secure now, though. No, we don't assume that. Anyway, the fact that it's always open makes it a good default for this tool. We get a connection time here, for, the key negotiation time, including the full key negotiation and the TCP establishment, I believe, is what that metric is. So from a random port on the client, obviously, to 135 on the peer. I'm showing some IKE main mode, so Internet Key Exchange main mode, Internet Key Exchange quick mode. These are part of the IPsec standard and specify the negotiated crypto parameters of the connection. So we're using 3-DES encryption. We're using SHA-1 hashing. And the key agreement was created via Diffie-Hellman. I don't know what curve or which parameters 2 corresponds to. But anyway, if you're a crypto weenie, you know that there's some P and G and some Y and some key size that implies. For the simplicity of the demo, I use a pre-shared key. There are some significant drawbacks for using a pre-shared key in an IPsec deployment. The positive side, the positive side of that, and the reason that lots of people do it, is that there aren't a lot of good alternatives. One alternative is to use a certificate on both sides, but that sort of implies that you have a PKI, a public key infrastructure, which means essentially that you're a big, rich company. The important thing to keep in mind about pre-shared key is that any administrator of a machine that's authenticated on that network, that has that pre-shared key configured on it, which it must if it's going to connect, any administrator of that machine can retrieve that pre-shared key. And so if you've got laptops where it's just regular users who have to be admins, otherwise when they're on the road they're screwed, right? They can get that pre-shared key and introduce new trusted machines into the network. So just be careful about how you configure IPsec. Yeah?
You know, Microsoft added that in Active Directory, they've now got they made it very, very simple to do PKI. So actually, for small companies, if you have all the machines, you roll in the same Active Directory, they get automatically enrolled into the same PKI. It's actually pretty darn simple.
Thank you. Let me expand on that comment. I'm not sure if this is where you're driving, but in Vista and later, there's an extension to IPsec. Embrace and extend. That's Microsoft's approach to standards, right? We support the standard, and then we completely break it. Anyway, the way they broke it is actually kind of beneficial for small companies, as this gentleman has observed. They introduced something called auth-IP. What auth-IP lets you do is say, well, forget about this pre-shared key crap. That's broken. You can still do the certificate thing, although there's still some infrastructure required there. But hey, let's support Kerberos. Let's say that if you already have an Active Directory infrastructure, you already have machine accounts, obviously, in that case, you can just do IPsec negotiation over Kerberos, which is awesome. I mean, that's really cool. That's a great feature. Another possibility is you can do IPsec over TLS now, or SSL TLS is another feature of auth-IP. So that's a very powerful new IPsec feature in Vista and Server 2008. So thank you. And then at the end of spewing out all this stuff, the tool disconnects the socket. And actually, this is a lie. It says the main mode and quick mode security associations are deleted. I actually couldn't find the API to do that. And I kind of forgot that I didn't find the API to do that. Anyway, I now have it. So if for some reason that this is like a real problem that you want to be able to programmatically delete security associations, just let me know and I'll tell you how to do that, because it's not in the code. It's not in the public version of the code. By the way, if you want to play with this, I'll send you the new version, because getting updated versions onto MSDN is like a glacial process. So I'll just email you the latest code if you want to play with this. Any questions? Yeah. Yeah, the question is about characterizing the amount of kernel mode code in the smart card data stack written by Microsoft. Let me say that there's a non-trivial amount of kernel mode code written by Microsoft that's involved in that smart card data path. Basically, the reader library, the reader driver that talks to this reader actually kind of plugs in as like a mini driver into a driver host that Microsoft wrote. Now, my assertion is that that's a pretty solid piece of code, because it's been around a while and it's been reviewed several times, and it's just kind of a dumb pipe, again, that just implements these smart card communication standards. But you're never going to hear me say that you won't find a bug in that. So please do try. Okay, that's it, guys. Thanks a lot. Oh, sorry. Dude, let me unplug and come down. Is that okay?